All right, lesson 5.5 is law of sines, and actually you're going to be doing an assignment that covers lesson 5.5 and 5.6 together because this lesson is law of sines and the next is law of cosines, okay? So they kind of go hand in hand. What we're going to be doing is we're going to be using this law of sines to help us find either missing sides or missing angles in an oblique triangle. Okay, so recap from geometry stuff. An oblique triangle is one that has one angle that is greater than 90 degrees. And we're going to be finding the other two angles or other angle or even side lengths. Referring to the formula itself, let me redraw this triangle. This is horrible. Let me try again. So we're going to be in this triangle using what we call A, B, and C. Okay, so A, B, and C are going to be side lengths and angle measurements. So let's start with angle measurements. We'll go like this. We'll go A. Those are supposed to be capital letters. My apologies. We'll take this one, call it A. We'll go here to B. We'll go here to C. Okay. In the formula, A, B, and C would be the capital A, capital B, capital C. Those would be the angle measurements. The lowercase letters A, B, and C, those are referring to the side lengths. And the way that it works is the side length A is directly across from angle A. Side length B is directly across from angle B, and so on for C. All right, so here is a triangle that they are calling an angle side triangle. Let's see why. So let's start with filling in the information that is given, and you can choose which angles you want to be A, B, and C. That really doesn't matter that much. Let's go. A is down here, that's 64. C is 82, and then side length C would be opposite of angle C, that is 14. So this is called an angle side triangle because if you kind of were tracing the triangle, you would have an angle, and the next thing that you would reach is another angle, and then the third thing along the path is a side measurement. So angle, side. Okay, our job is to find angle B, or side A, and side B. You can kind of start with whatever you'd like. So I think I'm going to go with, let's find side A first. So I'll go with blue. This would be side A. And in our formula, it's consistent of 3 fractions. You will only use 2 in each of your computations. So maybe I need to use sine A over A and then sine C over C. So I'm going to create a proportion with this fraction equal to this fraction, okay? You pick and choose what you need at that time. At this time, I need sine A over A because I need to find the value of A, the side length A. So I'm going to go sine A over A. I need that. And then my other fraction needs to be 2 things that I do currently know. So I can't use B because I don't know B, but I do know angle C and side C. So I'll go sine C over C. So this is what I'm going to use. I'm going to plug in what I know. I know angle A is 64. I do not know side length A. Angle C is 82, and side length C is 14. So this is our setup for the first part of our work. And to solve, we will be cross multiplying. So we would have A times sine of 82 degrees equals 14 sine of 64. Good news, these are all calculator problems. So you will grab a calculator to help you with the rest. Basically, I'm going to just use my calculator in the very last step. I kind of like to do all of the math first and then grab the calculator, meaning I know exactly what I'm going to type in. So 14 sine of 64 degrees divided by sine of 82 degrees. FYI, check and make sure you're in degree mode. Okay, so that is going to give us an answer of 12.71 inches. So we can put it in this little box over here if we want to. Okay, now I'm going to go ahead and go back and fill that in my triangle. So 12.71. All right. We still need to find angle B and side length B. All right, so let's go actually with angle B next. Now, angle B is not real complicated, is it? Because you're just doing, you could just use the fact that all the angles in a triangle add up to 180. So you could just do 180 minus 64 minus 82. And that would give you your angle measurement that you're missing. So that's going to be 34. So that just leaves us with one missing side. That would be side length B. So we're going to set up another proportion to find that value. So we're going to need to use sine B over B. We kind of have to do that because it's the only ratio containing the thing we're trying to find, which is lowercase b. And then you can use whatever you would like for your other ratio. I will go with sine C over C, kind of like I did last time. So sine of B is sine of 34. We don't know the side length measurement for B. Sine of C is 64 degrees. No, that's not right. 82 degrees over 14. Cross multiply, and you get B times sine of 82 equals 14 sine of 34. You will be dividing. Grab your calculator to help you with the rest. Again, make sure that you are in degree mode while you are typing. So this answer should end up being 7.91. I'm going to go up and fill that in right here. And that's it. Okay, let's try another example. So we're going to this time have a side-side angle triangle. Make sure that when you start, you're going to pick what you want A, B, and C to be. I think actually I'm going to make this one A because I kind of want it to look like the measurement given, and that's the only oblique angle. So that one is probably 123. So then I can go, maybe I'll go over here as B and this is C. Remember that side length A is across from A, so that's 47. Side length C is across from angle C, which is 23. So that would be what our triangle looks like set up. The first thing that I think I'm going to do is find angle C. So we're going to find this thing here. I need sine C over C to find that missing C value. And then I do know A and its side length, corresponding side length. So I'll go sine A over A as the second ratio that I choose. So sine C over 23 is the side length C is equal to sine of 123 over 47. And this, kind of the hard part has been done at this point. You're just going to cross multiply and divide like we did before. Okay, now there's going to be an additional step. So watch me. Right now what I have is I have sine of C is equal to 23 times sine of 123 divided by 47. I'm not real sure what that actual number is. I'm not going to type it in the calculator yet because there's going to be another step. Now, do you see how we're looking for an angle this time, but the sine is in front of it? And the only way to make the sine go away is if you apply inverse sine to it. And if I apply inverse sine to it, I have to do that on both sides of my equation, right? We have to balance the equation. So on both sides of the equation, I'm going to apply inverse sine. And again, the purpose of that is to make this sine and the inverse sine cancel each other out, leaving you with angle C. So all of this stuff over here is what you would be typing in your calculator. Make sure you're in degree mode. You're going to get an answer of 24.23 degrees. Okay, so that's our missing angle, 24.23 degrees. Okay, you will continue your work. I would say now it makes the most sense to find angle B. You can do 180 minus 123 minus 24.23, and that will give you your missing angle measurement down here. That is going to be 32.77. Okay, one more step, and that is to find side length B, which is basically just going to be a repeat of all the work we kind of did here, or that we did in the last problem. So I'm going to just set this one up, and I'm not going to show you all the steps this time because it's really just, you know, that same cross multiply process. So I'm going to choose sine B over B because I need to find B, and sine A over A because I already know those. And that's going to look like sine of, let's see, 32.77 divided by B, because I don't know that, equals sine of 123 divided by 47. Cross multiply and divide, I'll give you your final answer. That should end up being 30.33. Okay, let's look at some weird cases. Okay, so here is an interesting case. This particular question, I'm going to set it up, but something different is going to happen. So we're going to label what we know. We know A is 50. We know side A is 10. That would be that side. We know 20 is our other side, or side B. So let's just start going through the process of finding, oh, I don't know, angle B. So we're going to find angle B. Okay, I'm going to have to use sine B over B if I want to find B. And then what else do I know? I know angle A and side A. So let's go sine A over A since I know both of those values. Plug in what you know. I know side B is 20. I know A is 50. And I know side A is 10. Okay, cross multiply. You will have 10 sine of B equals 20 sine of 50. And we would be dividing by 10. Okay, so next step is we have sine of B equals, maybe you can even go ahead and divide that because this would just be 2 sine of 50, right? Okay, this is where I'm going to have to apply an inverse sine to each side of the equation because I want to find the angle measurement and I need the sine to not be there in order to do that. Okay, so this inverse sine and the regular sine are going to cancel each other out. Now I'm going to type in the calculator. Make sure that you're in degree mode. Inverse sine of 2 sine of 50 degrees. What happens is when you type that in the calculator, you get a domain error. Okay, simply that just means that this is not solvable. It's not something that exists in the domain of inverse sine. So there is no way to get an answer, okay? What that means is that this is not a possible triangle. It is not possible to draw a triangle where one angle is 50 and then the A and the B values are 10 and 20 like this, okay? So maybe we'll say no possible triangles. At this point, you would be done. You just say, not solvable, no possible triangles, I am done. All right, let's take a look at an application question. So it says we have 2 fire lookout stations that are 13 miles apart. So maybe this is station 1 here and this is station 2 way over here. And there's 13 miles between them, like this. Both stations spot a fire. Oh, by the way, they call them station A and B. Whoops. Let me relabel that. So station A is to the east of station B. So, or B is east of A. So this would be A and B, like that. Okay. Both stations spot a fire. The bearing of the fire from station A. All right. So there's a fire. We'll just say right here, there's a fire. Isn't my drawing spectacular? It says the bearing of the fire from station A is north 35 degrees east. So that means if you were at station A and you look straight north and then turn to the east 35 degrees, that would be your angle measurement. Okay? Same thing over here. B, if you look north and then turn 49 degrees west, that would give you that angle measurement. Now, we don't need those. We actually need the ones inside of this triangle. So let's use them to help us find what we need. If this is 35, our triangle makes a right angle with that. So we're just going to subtract from 90 to find the missing measurement on both of these. So this would be 55 and 41. Okay. Now what we can do is we can answer the question, how far to the nearest mile is the fire from station B? So we need this value only. If you look at our triangle setup, it appears that we have angle A, and this is a cross. So this would be like A in our formula, our law of sines equation. This angle is not given, but we can do 180 minus 55 minus 41 to find this missing angle measurement. So that missing angle measurement is going to be 84 degrees. And that means that this would be opposite of that. So kind of like C and C. So I'm going to write sine of C over C equals sine of A over A. And let's set this up. So I'm going to say sine of C is like 84, and opposite of that is 13. Sine of 55 over the missing side, call it A, call it X, whatever, it doesn't really matter. And then cross multiply. And divide by sine of 84, and you are done. The answer to this question is 10.71 miles, but it says to the nearest mile, so we would say 11 miles.